Well, hello and welcome back to another episode. It's great to see you all. I hope you're doing well. So today I wanted to talk about something a little bit different, to make a bit of a change from the very academic content that I post most of the time. And I wanted to talk about the fireworks animation that you can see going on behind me. Now, I've used this for a couple of videos. I made it originally for a video for New Year's, and then I used it again to celebrate reaching 1,000 subscribers, which as a regular viewers and subscribers to my channel will probably have seen already. And I thought it would be interesting to talk a little bit about how I actually created it. Now, I created this using Python and the Pygame library, which is a combination I like to use quite a lot for creating effects for videos and things like that, and I think it works really quite well. So hopefully that will be interesting. I don't want to do a long introduction, so we're going to jump right into it. Just want to say quickly before we do that if you like this video, please do remember to hit that like button, and if you haven't done so already, please consider subscribing to my channel and hitting the bell icon for notifications so that you don't have to miss any future videos. Thank you very much. Right, let's jump into Python and see how we can make this fireworks animation. Okay, so here we are in Python. We're going to take a look at the code, but this is actually what we're going to create, is the animation that you can see here. And this does kind of run in real time, although that hasn't been an objective of mine with this code. My intention with this code was always to use it to render frames that I could then use in videos. So real time wasn't really important. If you increase the number of fireworks, number of effects, then it will slow down quite considerably. But it does give, as you can see, I think really rather pleasing results. Now, of course, I'm well aware that there are more efficient ways of doing this using Pygame than the way I have. But we'll take a look at the code and see what we think. But like I say, it was code I wrote to solve a particular problem that I had to create these firework animations, and it works perfectly well for what I wanted to use it for. So there we go. So with that caveat in mind, let's close this. And let's go ahead and take a look at the code, which you can see here. So it's just one .py file. I called it fireworks.py. Of course, you can call it anything you want. And of course, I wrote this back in December last year because I used it for a New Year's celebration video thing that I made. Okay, so the first thing that we do is we import Pygame, we import random, and we import numpy as np. So I'm assuming that you will have these already installed and set up in your system, whether you're using a virtual environment or however you're choosing to do it. This is not intended to be a beginner's tutorial for Python, so I'm not really going to cover that. So I assume you have Pygame and numpy installed and set up already. So we're going to create a number of classes. In fact, we're going to make three. The first class that we create is called QB_Spark. Now, this is the class that handles the individual sparks. So each time when a firework goes off, it ejects a number of individual sparks. Each one of those sparks is an instance of this QB_Spark class. Inside the QB_Spark class, we have a constructor defined in the standard way, which accepts as input the initial x and y coordinates, the initial x and y velocities for the spark, the initial color, and the lifetime. Now, an important thing to note about this, the way I wrote it, is that all of the firework effects are actually pre-generated and then played out for the duration of the animation. They're not created as it goes. So if you leave it running, eventually it will come to a stop. It doesn't just run forever. Since my intention was to use it to create frames for videos, that's really perfectly acceptable for what I wanted to do. So we define initially some user-defined variables. So in fact, actually, we just copy those from what's been passed into the constructor function for initial color. We set the final color to 0, 0, 0, which of course is black. Set the lifetime to whatever the lifetime was, and the same with init_x and init_y and init_vx and init_vy. So that's pretty obvious. We then have internal variables to store the current color, simply called self.color, self.x, self.y, self.fx, and fy. These are floating point versions of x and y. We need to store two copies of those because we have the integer versions of x and y, which is the location to which we actually draw the firework on the screen. So that obviously has to be an integer. But when we're dealing with the velocity and the step size and things, we use the floating point position, because then that allows us to have subpixel accuracy. Otherwise, it doesn't really work. You get really rather weird effects. Anyway, and we store the velocity, Vx and Vy exactly the same. We set our frame counter to 0, and we have a flag to say whether the spark is active or not. We start off with self.active equals true, and the purpose of this is so that once the spark reaches the end of its lifetime, we can indicate that it's no longer active, and we no longer need to waste any time trying to render it. So although I wasn't aiming for real time, I did make some effort to make it run as fast as possible. It does get very, very, very slow. If you were to, you can imagine every time a firework goes off, it creates, several tens of these sparks. The numbers would add up very quickly. Okay, we then pre-compute colors for the color fade, or values for the color fade, because we've got the lifetime already. We know the initial color, and we know the final color. We can actually calculate the step size we need for this R fade and G fade and B fade, which is just the initial red minus the final red divided by the lifetime. Okay, so we'll talk about how we specify lifetime and initial colors in a moment. Okay, so once we've done all that, that's fine, that's that. We then have a tick function, so this will be called every time we loop through the main loop. If you're familiar with how Pygames work, Pygame library projects work, you have a main loop that simply loops continuously. So every time we come through that loop, the idea is that the tick function within this QBSpark class will be called, and it's responsible for updating all of the internal variables. And as you can see, the first thing it does is update fx and fy. These, as I just said, are the floating point versions of the position, and we just do self.fx plus equals self.vx and self.fy plus equals self.vy. So that's simply going to modify the position in x and y according to the velocity. And we then set the integer versions of those. Self.x is simply the integer version of self.fx, and the same for y. Now we're then going to update the velocity of the spark in order to simulate gravity. Now I've chosen a value here that looks good at 30 frames a second. If you're using a different frame rate, you'll want to change it. This is not a physically accurate simulation. Okay, so just adjust the value to give something that looks meaningful. So I've just got self.vy plus equals 0.05, and the effect of that will be to, every time we come through tick, we increase the y velocity by 0.05, so there'll be in effect an acceleration downwards in the vertical direction, hence simulating the effect of gravity. Okay. We're then going to update the color. We've already calculated R fade, G fade, and B fade, so we simply calculate the color. It's easy enough. We extract new red, new green, and new blue from self.color, and then we modify them according to this. So we set them to the maximum of 0, or this value here, the new red minus self.r fade. Okay, so the point of using maximum is essentially to constrain it so it can't go below 0. So it's either going to be 0 or the value of this, whichever is highest. Okay, and the same for green and the same for blue, and then we update self.color. And we now update the active flag. So we check if the frame counter, which is our indication of where we are in the animation, is greater than or equal to the lifetime of the spark, then we set self.active to false. So if the spark has reached its lifetime, then we set we say that it's no longer active, so we set the self.active flag to false, and we update our frame counter to measure the lifetime. And we then have one last function in this class, which is to actually render the spark to the screen. And again, this is designed to be called every time we come through the main loop. So in the main loop, we will call the tick function, which updates everything, and then we call the draw function, which is responsible for actually drawing the spark onto the screen. And that's really very simple. It just checks if we're active. If we are, then it uses pygame.draw.rect to display surface. We're going to come to that in a moment. Self.color and pygame.rect. This is where we draw. We're drawing 4x4 pixel rectangles, and we return new rect, which is the area of the screen to which we've drawn, else we return none. Okay, so pretty straightforward. And this is the bit that I think is probably not as efficient as it could be. I think perhaps pygame.draw.rect is not that fast. We could do this, of course, by rendering a sprite or something like that. But, like I said, real time was not really my objective, so I didn't worry too much about that. Now we have a second class, which is a class for the actual firework. So this is class QB Firework. Now this firework class is going to contain a number of sparks. Okay, so this is the overall firework, and it contains a number of instances of the spark class. Okay, so we define this with an X location, a Y location, a start time, and a start color. Okay. In the constructor function, we simply copy those to the internal variables. We set the number of sparks. It's fixed for every firework at 100. We initialize a self.frameCounter to 0. We use a self.active flag in exactly the same way as we did for QB Spark, except this is, of course, for the overall firework, and its purpose is exactly the same. It will indicate whether this firework is currently active or if it's expired, if it's finished its effect, in which case, of course, we don't need to do anything with it. And we set up a empty list for self.sparks, okay, which is obviously where we're going to store the sparks. Right. Now, in exactly the same format as we had for the Spark class, we now have a tick function, tick self here, and what we do first is if frame counter is equal to the start time, then we create the spark. So the idea of this is that because we want to pre-generate everything, when we create the firework objects, we give them an assigned start time, or what time the effect will begin in terms of frame numbers. Again, because this is all intended to be pre-rendered and pre-computed, not run in real time. So if the frame counter is equal to the start time, then we want to do stuff. Otherwise, obviously, we don't do anything. Okay, assuming that frame counter and start time are the same, then we come into here and we loop through all of our sparks for I in range 0 to self.num sparks, okay? And we're going to compute random velocities in x and y. And this is a really interesting point here, that we compute the random direction and speed in polar coordinates, and then we convert it back to Cartesian coordinates to actually plot it. Now, it's very interesting if you don't do it this way, and I would encourage you to have a go with this, experiment with it, and you'll see what I mean. But if we don't do it this way, then the diagonal velocities end up being proportionally larger than the purely horizontal or purely vertical velocities, because, of course, you're talking about then the distance is like the square root of 2, from the center to the corners of a square is a longer distance than from the center straight out horizontally or vertically. And the effect of that is that you end up with a perfectly square formation. As the sparks eject, they come out in perfect squares, which is obviously very unrealistic. We don't want that. So we use polar coordinates, and then we convert to Cartesian. So we set up a random direction using random.uniform from 0 to np.pi. This is the only reason I've used the numpy library, actually. By the way, it's just for pi. You could replace that with a constant. But anyway. We then set random speed as random.uniform between -2 and 2, so it's going to go in either direction, up or down, left or right. And then we're going to convert those into x velocity and y velocity simply here. So xv is equal to rand speed multiplied by np.sine. Oh, actually, apologies, I did use, of course, numpy for sine and cosine as well. Forget my last comment about numpy there. Yep. So rand speed multiplied by np.sine of rand dir, and then the same for y velocity is np.cosine of rand dir. And that will give us random velocities that will give a nice circular explosion effect as the firework explodes. And we then compute a random lifetime for each spark. So I've chosen values that give a range between 1 to 4 seconds at 30 frames a second. So lifetime is equal to random.randint 30, 120, so range from 30 to 120. If you're using a different frame rate other than 30 FPS, you will need to modify these values to give the effect that you want. And then we actually generate the sparks. So we simply do self.sparks. Remember, self.sparks is the empty list we created here for the spark object, and we append to that a new QB spark object initialized with self.initx, self.initY, xv, yv, self.startColor, and lifetime that we've all set all of those things there. Okay. Now, if when we call self.tick our frame counter is greater than start time, then we actually want to tick the sparks. Okay, so this just happens at the initial creation of the firework. At its particular start time, we create it. If our frame counter is greater than that time, then we want it to actually animate the sparks. So we detect that. We have elif self.frameCounter greater than self.startTime. Then we set numActive to 0. That simply counts how many active sparks we have, okay? Or we're going to use that to count how many active sparks. We loop x through self.sparks, and then we simply call x.tick. So that's going to call the tick function in each of the spark objects, as we've just talked about. And we check if that spark is still active. So if x.active then we increment num_active by 1. Okay, so if there are no active sparks, you remember the lifetime of the sparks is random and finite. So as the frame counter ticks upwards, eventually there won't be any sparks left that are active. In that case, we set the active flag for this particular firework to false. Okay. That's all of that. So otherwise, the frame counter must be less than start time, in which case we don't do anything, so else : simply pass. Okay, so we do nothing. If we haven't yet reached the start time of this firework, then we don't need to do anything at all. Okay? Okay, and then we come to the draw function for the firework in the firework class. So exactly as we had for the Spark class, we have a draw function that's called every frame or every time through the main loop, and it's responsible for actually rendering the firework. And it simply detects if our current firework is active and if frame counter is greater than start time, then we loop through all of the sparks for x in self.sparks, if x.active, x.draw display surface. So what this does is it calls the draw function for each spark passing display surface. We'll come to that in a moment. If x.active, so if that spark is active, and for all of the sparks in our list of sparks defined for this particular firework, if this firework is active. So I tried to make it as efficient as possible, otherwise, as you accumulate more and more sparks, it gradually gets slower and slower. So if the sparks are not active, they're not rendered, and if there are no active sparks, then the firework itself is declared inactive and it's no longer rendered. So they're just, although real time wasn't really what I was aiming for, I still did try to save as many CPU cycles as possible. Okay, then we come to the third class, which is the actual application class, so just class application. This defines in its constructor our initial state. We have a flag is running as true, display surface initially 0, FPS clock I don't think I actually use, but it's set to none. We initialize an empty list called self.fireworks into which to store the fireworks. We set up the size, width and height of the frame size that we want to create. It now at the moment set to 1280 by 720. You can set that to whatever size you want to create the frames for your animation. We're going to create 500 fireworks over 1,800 frames with an output count initially starting at 0, and you can specify an output path. Now that's used for rendering the frames out to files. It renders each frame out to an individual PNG, and then you can read those into whatever video editing software you use. So specify the path there that you want. Okay, and then we come to onInit. So this is the initialize function. We can call this to initialize things. This then does pygame.init, which initializes pygame, do pygame.display.setCaption. Happy New Year, because like I say, I created this to celebrate New Year. Self.display surface is equal to pygame.display.setMode and then self.size. So very, very simple. That creates a display surface of 1280 by 720 in this case. And so that's straightforward. And we set self.is running to true. We then loop through all of our fireworks, so for I in range 0 to self.num fireworks, so we set that to 500 up there. We set a random start time as a random integer between 1 and self.num frames. We set x and y locations, so notice these fireworks don't fire up from the ground. I'm assuming that you can't see that part of what's going on, so I didn't worry about it. So they have an initial x and y random locations, so x is set to anywhere across the width, height to anywhere within the top half. RG and B, random colours set to between 0 and 255, and self.fireworks.append, and then we create a new QB firework object with those parameters. And that's it. That will then go through and in this case create 500 fireworks, all with random start times uniformly distributed across the number of frames that we want. Okay, we have on event function that is responsible for handling events. This is standard Pygame stuff. If the event is pygame.quit, then we set self.is running to false. Okay, so that's just a flag that we'll see actually in a moment how that's used. Okay, so we have an onLoop function here, onLoopSelf, which simply loops through every firework. So this is called every time we go through the main loop, and we just have for x in self.fireworks. If x is active, then we call its tick function. So that's going to call the tick function to update every firework, and inside each firework instance of the firework class, it will call the tick function for every spark, and so hence everything will update, and we should get the animation that we want. And we then have onRender self, which is actually responsible for creating the display. It initially does self.displaySurface.fill to 000, which of course will just reset the display to black, and then we're going to loop through all of the sparks and render, which we can do incidentally by simply looping through each firework. So we do for x and self.fireworks, if x.active, then call x.draw and pass to it the display surface. So that will call the draw function for the particular firework that will then go on to call the draw function for all of its sparks. So at this point we only need to worry about that, which I think is quite neat. And we then have pygame.display.update that actually updates the display before we move on. Now, if you wanted to output the frames to separate PNGs to use them, incorporate them into some kind of video, which is what I do, then you specify a file name as being some path, and then followed by frame %04d.png, %self.output count. It's what we use output count for. So then you'll get frame 01, 0001, frame 0002, frame 0003.png, and so on. And then use pygame.image.save, self.displaySurface, and that will save those out. I've commented those out because I don't really want to create more frames at the moment. And then we simply increment output count, and there we go. And we then have on execute, which is the code that we're going to call to actually make the application run, and it calls self.onInit. If that returns false, then it sets self.isRunning to false. And this is the main loop that I've been talking about. It's really just this code here. So simply while self.isRunning is true, we just loop through this. We loop through every event in pygame.event.get, and we call self.onEvent. Now, as we saw that before, the only event that we're actually interested in is here. If we have event.type equals pygame.quit, then we set self.isRunning to false. Okay, and as we can see, if self.isRunning is no longer true, then we drop out of that loop and call pygame.quit. That will quit everything and tidy everything up. Otherwise, if we keep running through this loop, we call self.onLoop and then self.onRender. These are the two functions that we've literally just looked at there. And that's it, really. And then the main part of the code here, if __name equals main, then we set up an instance of the application class t equals application and simply call t.onExecute, and it will run. And that's it, really. And to make it run, easy enough, just go to our terminal window. And I'm just in this folder here. If we do ls-l, we see we have fireworks.py. I'm already in my virtual environment here. I'm assuming you know how to set things like that up yourself if you want to. And we just do Python 3 fireworks.py, run that code, and there we go. And we get exactly the effect that we want, which I think is pretty cool, actually. I mean, yeah, and there's a lot of parameters there you could change and play around with, set the frame size, whatever, however you want to do it. But yeah, a simple effect, but I think yeah, quite effective. So there we go, that's really everything I wanted to talk about today. We've had a quick look at the Python code and how we can use Python along with the Pygame library to create animations such as the fireworks animation that you can see going on behind me. I really hope that was of interest. Anyway, it's been a great deal of pleasure making this video. I hope you've enjoyed it, and I really look forward to seeing you in the next episode. Thank you very much for watching. Bye.